Okay, in this video we're going to continue looking at, or begin looking at, logistic models. Now, in the exponential growth and decay model, it assumes that the population increases forever. But, of course, this is not possible because there are limiting factors such as food, living spaces, and other resources that a town or a city cannot continue to grow without bounds. Generally, the population is capped, and we call that the carrying capacity. And it's capped based upon space, based upon food and other factors that an area can only grow but so much. And so a more realistic model of population is a logistic growth model. And if you would recall from pre-calculus, and you need to write this in your notes, the logistic growth model for pre-calculus is given by the following formula, where M is the carrying capacity and K is the growth rate. Note that A is not the initial amount. A is not initial amount. Now, we will use this formula in this class. However, you should never use this formula on the AP exam. All questions on the AP exam must be done using calculus. So if they give you a logistic growth model in a free response question, you would have to use separation of variables to solve it. You may not use this formula on the AP exam. However, we are going to use it. I think you need to use it for your quiz. This is a logistic growth model. You probably remember this from pre-calc. And this point of inflection is where the function is growing the fastest, and it's always at half its carrying capacity. So whatever the carrying capacity is, it's growing the fastest when it's half that amount. And that's a question that shows up a lot on the AP exam as a multiple choice question, so that's something good to know. You want to put a star by this and remember that. It's not in your notes, so you want to write it down. But it's always growing the fastest when it's half its carrying capacity. Excuse me. This is the calculus logistic differential equation. You need to know this equation, sorry, and you need to be able to manipulate an equation until it's in this form. That's either going to be done with differential equations and separating the variables, or they will give you this function and you just need to factor to get it into this form. All right, let's do an example. So we're told that the growth of a population is modeled by this differential equation. Now, we're not going to have to separate variables to do this. As a matter of fact, you can't separate these variables until we do partial fractions, and we won't do that until next week. So how do we find the carrying capacity? Well, what we want to do is we want to put it in this form. So notice in this form, this is 1, and we have P over M. So to do that, what we're going to need to do is factor out. This needs to be 1. So in order to make that 1, I'm going to factor out 100 from this equation. So dp dt. So when I factor out 100 from here, I am multiplying this decimal by 100, so it becomes 0.8 p. And then when I factor out 100 from here, I get 1, but I have to factor 100 from here too. It doesn't have it to give, so it becomes p over 100. Once it's in this form, I can answer all of these questions. This is the only math that we have to do. So the carrying capacity now is 100. What is the bad population when it's growing the fastest? Well, it's growing the fastest when it's half its carrying capacity. So that would be at 50 bear. What is the rate of change of the population when it's growing the fastest? Well, we have the equation for dp dt. This is how fast the bear population is growing. So to find dp dt, I simply just evaluate this expression. So 0.8 p in this case would be 50. And this would be 1 minus 50 over 100. And you can use your calculator to solve that, I think I did it wrong when I did it. So it would be 0.8 times 50 times 1/2. So approximately 20 when it's growing this fast. So it's growing the rate of change at which it's growing is 20. That doesn't really make sense. dt is 1 minus okay, so I guess 20, it's not 20 bar, but it's, I guess 20 bar per minute or 20 bar per hour. I don't know how fast this is growing. It doesn't say. Oh, measured in years, so 20 bears each year. That's the rate at which it's changing. Okay? And then what is the limit as t approaches infinity? Well, the limit will always be the carrying capacity because it's going to reach its carrying capacity and then slow down. So the carrying capacity would be 100. Okay, now for this question, and you have a question like this on your quiz. Okay, so you want to make sure that you can do a question like this for your quiz, and on this question we're going to have to use the calculator model. So we have 10 grizzly bears were introduced to a national park 10 years ago. So our initial population was 10 when t was 0. Currently there are 23 bears, so 10 years later there's 23 bears. And the maximum that it can support is 100. So that's going to be our carrying capacity. Okay? So we're going to use the pre-calculus formula for this. So this is P is equal to our carrying capacity is 100. And remember, we're getting this formula from that the first one that we wrote. Let me write it out for you. P equals M over 1 plus A e to the negative kt. Okay, and you should recall this from pre-calculus as well. Remember, A is not our initial condition, so A is not 10. So we have 100, 1 plus A e to the negative kt. So we're going to take this first bit of information, the initial population, to actually find A. So initially there were 10 bear in the introduced, and this is 1 plus A e to the negative k, 0. So anything raised to the 0 power is 1, so I end up with 10 is equal to 100 over 1 plus A. I mean, e raised to the 0 power is 1, so it becomes 1, and I just have A here. And right now, this is just algebra, so I'm going to do this quickly. I get 1 plus A is equal to 100 over 10. Therefore, A is equal to 9. Okay? So now I have to find K. I'm going to use this equation again. This time I know A, and I'm going to find K. So I have P is equal to 100, 1 plus 9 e to the negative kt. Alrighty? Solving for K, I'm going to use the second information that I was given, that the population is 23. And T is 10. Okay? So again, this is just algebra. I'm going to do this quickly. I'm just going to do it quickly. You should be able to do this. So this is 1 plus 9 e to the negative 10k. I'm cross multiplying. Is equal to 100 over 23. I subtract 1 from both sides. I get 9e to the negative 10k is equal to 100 over 23 minus 1. I divide by 9. Divided by 9, and then I take the natural log of both sides, so I get negative 10k is equal to the natural log of this beautiful thing here. And again, you can use your calculator. I don't have a calculator with me right now, which is why I am not. This is the natural log of all of this. So K is equal to the natural log of 100 over 23 minus 1 divided by 9 divided by negative 10. And I think that answer is 0.109427. If you put that in your calculator, I think that's what you should get. So my equation then is P is equal to 100, 1 plus E to the negative, and K, let me erase that. Oh, I can leave that. 0.109427 T. Okay? So then the question asks, when will the population reach 50? So I would put 50 here. And then I would solve for T. That looks like fun, doesn't it? I'm just going to abbreviate that. Remember, you always want to go 3 places behind the decimal. And let's see if I can just finish solving this. I multiply both sides by, I cross multiply really. So this comes up here and then that's going to go down there. So I get 1 plus e to the negative 0.109 t is equal to 100 divided by 50, which is 2. So e to the negative, wait a minute, did I lose my a? I lost my a. There should be a 9 there. Sorry, I lost my a. So 9e to the negative 0.109t is equal to 1, subtracting 1 from both sides, dividing by 9, and I get e to the negative 0.109t is equal to 1/9. Taking the natural log of both sides, I get negative 0.019t is equal to the natural log of 1/9. And then solving for t, I got t was approximately 20 years. Okay? And then, of course, you can do that for 75 and 100. I wouldn't recommend it, but if you need the practice, you can do it. You can also use your calculator to solve that as well, because you would need your calculator anyway. So to use your calculator to solve this, you would make P equal to 75. So you put in Y1, 75, Y2, this equation, and just see where they intersect. Okay, so here's another type of question that you would get. It would be a multiple choice question, and it's just want to know, what is the carrying capacity? Okay, so again, we have to put it into this formula. Remember, the formula is dp dt is equal to kp and 1 minus p over m. So we need to get it to look like that. So the first thing we have to do is divide both sides by 6 to pull out a 6p. So 6p would be our greatest common factor. So we get 6p, and this would be 1 minus. Okay, so what I'm going to do is I'm going to take 0.012 divided by 6, and then I'm going to do math fraction. And when I do that, I get 500, p over 500, which tells me that my carrying capacity is 500. It's growing the fastest when this is 250. The limit as t approaches infinity of piece of t is 500. So that gives me a lot of different information. Okay, that is logistic function. So thank you for watching and have a great day.